All right. Hello, I am Christian Stevenson with the Mississippi State University Extension Service in Hancock County, and I am coming to you through Zoom to give you a presentation on composting. And I want to start off just by talking to you about what compost is. Compost is really just a partially decomposed plant material, usually mixed in with soil. And Compost is really rich in organic matter, and because of that really rich organic matter, it can be very useful for fixing a lot of things that might be going wrong with the soil that we're trying to garden in. Adding organic matter can improve the structure of soil, address the problem of your soil being too sandy or too heavy in clay, really improve its fertility, as well as increase its ability to hold water and nutrients that are really important for plant growth. One of the advantages of compost is that it is relatively easy to use. So you can mix that directly in with your garden soil. You can use that as a mulch to just go over the top of your soil, or you can mix it with the soil actually after the growing season is over. It's really easy to handle. And essentially, you can store compost indefinitely. So it's not something that has a time limit on when it can be used in the landscape. Now, the biggest benefit of compost is as that soil conditioner that I already referred to. Again, increasing that water holding capacity. It's going to reduce how often you need to water. It's really going to hold that water right there in the soil where the roots can use it. And if you recall some of our previous conversations, one of the issues that we really want to address, particularly with vegetable crops like tomatoes, we really want to make sure that we're not having big swings in water availability to the plant. That helps us address problems like blossom end rot. So again, adding that compost is really going to help us improve really sandy soils or clay soils. Going to provide some nutrients like nitrogen and phosphorus and potassium, as well as a lot of the other micronutrients that are needed by the plant. And those nutrients are going to be in an organic form, which just means that they're in more complicated organic compounds. That means they're going to break down more slowly to be available to the plant. We don't have quite as many problems with them leaching out in response to water moving through the soil. Now, in addition to the benefits of composting for our gardens, composting has some pretty significant benefits environmentally. So a lot of the materials that we can turn into soil through composting would otherwise wind up going into a landfill. So of the materials that actually do go into landfills, about 30% of that material are things like grass clippings and leaves and yard wastes. And there is a U.S. Composting Council. They estimate that about 67% of what we are throwing away out into landfills can actually be composted and turned into a really great soil for our landscapes, for our gardens. So composting is really ecologically sensible, it's environmentally safe, and it reduces waste. And along with that, very often we are paying for our garden soil. We're buying it either in bags or having it delivered in bulk. And composting is a great way to make use of that material. And essentially, it's recycling on the scale of your home. So as far as what composting is really the management of the natural decomposition process of organic matter. And for that to happen, we really need four things. We need microorganisms. Those are the good bacteria and good fungi that are going to be in that material that are breaking it down. We need the organic waste materials that they're going to break down. And then we need oxygen and moisture because those living organisms require those things for their life. So for compost to form, organic waste goes through what we call a thermophilic cycle or a heating cycle. And that is driven by the decomposition of organic matter by these microorganisms. And that heating cycle can take a good while to happen. So it may take 6 months for your compost to be fully worked. So here's just an easy way to look at the process of composting as it goes through its different stages. So you start off with your organic waste material, whatever that material may be, and initially the population of microorganisms that are in that material are going to be relatively small. As they're growing, as they're enjoying the material that they have to eat, the population is going to increase fairly rapidly. And as that happens, because of all of the physiology they're undergoing, all of that reproduction, all the introduction, all the buildup of those microorganisms, the temperature inside that compost pile is going to increase. So we might start off, we start off at whatever temperature it is outside. As those populations are increasing, the temperature of your compost pile is also going to increase. So we'll start off, you get into an area where your temperature might be anywhere from 95 to 115 degrees Fahrenheit. And over time, that temperature is going to continue to increase. Eventually, you'll get to a stage we call the thermophilic stage, where the temperature of your compost pile can get up to 160 degrees. Will actually really feel warm to the touch. And as the temperature increases, the microorganisms undergo a lot of different population changes. So the ratio of different bacteria and fungi in that compost is going to change. Now, eventually, they're going to start running out of their food source. They're going to have broken down a lot of that material. And so that temperature is going to decline again and get into that second mesophilic stage. So we started off at essentially the temperature it is outside. We started to warm through that first mesophilic stage, got up to the thermophilic stage where that compost is really warm and really working. And then as those populations decline, as their food sources beginning to exhaust, that temperature is going to decline again down to about 95 to 113 degrees. And finally, as the compost is finished, its temperature is going to match, again, whatever the temperature is outside. And that's really important for us to understand what stage our compost is in, because we can actually use a big thermometer or a compost thermometer to monitor the changes in temperature, which allows us to indirectly monitor the changes in these bacterial and fungal populations, and allows us to know when our compost is ready to be used. So, of course, what we really want to do is learn how to build a compost pile and do that effectively. Now, we can build a compost pile really just by making a pile. You don't have to have a bin. Oftentimes we do that just to keep it contained, keep it all in one place and easy to work with. But you can absolutely just build a compost pile as an open pile. If you do use some way of containing that, whether that be cinder blocks or a wire fence, one of the things that I've seen that works very well is using old pallets to contain the area where the compost is. You do want to make sure that air and water are going to be able to get into that compost pile. Again, we do need oxygen and water for the good of those bacteria and fungi that are working in the soil. Now, to start off, what we want to do is we want to spread a layer of organic matter, whatever organic matter we're using, about 6 inches deep, and add about a cup of a mixed fertilizer. I know I say 688 there, but it's certainly not a problem to use 888 or 888 fertilizer. And you want to add about a cup to each 10 square foot of surface of your compost. Add about an inch of soil on top of that, and just enough water to moisten but not soak down the pile. I'm going to talk a little bit more specifically about how much water should be in there before we're done today. And then you can just kind of continue this process. So on top of that soil that you've added, you can add another 6 inches of organic matter, and the process just kind of continues on as you stack up that compost pile. So here's just a diagram of that. You can kind of see the different layers where you have your compost, your organic matter, then a layer of soil, and then a layer of a little bit of fertilizer, just to make sure that everything is exactly the way that you would want it. And so again, your compost pile can really just be a pile that works perfectly well and will absolutely go through the composting process just by piling it up and allowing that process to go. And here's again a diagram that kind of more specifically shows you the organic matter. Here they've got the fertilizer and then soil. That's perfectly okay. The chief thing with that fertilizer is it's adding in a little bit of extra nitrogen that allows those microorganisms to thrive in that environment. Here's just a few examples of some simple compost bins. I mentioned that you can use pallets as a simple way to contain that. I always like to bind them together. You can use wire on them, so you can detach that. The swing one side open so that you can access your compost pile and work with it. And a simple round wire system works really well also, just to make sure that you have that compost pile in kind of a convenient space. And of course, we don't want something in our landscape that's going to be unattractive. So just containing our compost like that really does work well, just to kind of make it look a little bit more intentional, so that our neighbors don't get mad at us for having just a big pile somewhere in the backyard. Now we can also use what we call a three-stage compost bin. And it's just what it sounds like. It's going to be a compost bin that has three different containers. So in our first container there, we're adding in that organic matter. We're letting it start off. And then as it begins to work, we're going to transfer that into the second bin, mix it all together there, let it get up through that really higher temperature stages, start to decline, and then move it over into our finished compost bin in order to finish off. Here's a good example of that. You can see it's done, but it's backwards because we are going from right to left in this instance, with that initial compost material coming in to the right side, beginning to get working. And then as it's working, we're transferring it into the middle bin, allowing that to really go through those heating stages. And then lastly, moving it over into the final bin, which really acts as a storage bin for that finished compost. Now, to talk a little bit more specifically about the process of composting, what we're really wanting to consider is that what we're adding into our compost bin is the food supply for the microbes that are doing the work. And when we think about that food supply, the two most important things to consider are the levels of carbon and nitrogen that are contained in these materials. And carbon really acts as the energy source, while nitrogen is there for population growth, and really builds up that decomposition process. So it's important that we have the right ratio of carbon and nitrogen in order to get the right mix to get a really good, quick growth of those microorganisms and really rapid decomposition. What we're looking for is a ratio somewhere between 25 and 30 to 1. So that's carbon to nitrogen. And oftentimes when you hear compost talked about, you will hear things like brown materials and green materials, or brown compost and green compost. Any brown material really is a high carbon, low nitrogen material. So things like leaves or newspaper, cardboard, these are all materials that have a lot of carbon, but not very much nitrogen. Where green materials are going to be things that have a much higher amount of nitrogen and less carbon in them. So things like the fruit and vegetable waste that we might generate in our kitchen, things like cow manure or coffee grounds, are all going to be what we consider to be green materials. Now, when we think about all of these different things, we can get a little bit tied up with what that carbon to nitrogen ratio would be. And so this chart really kind of puts together what the carbon to nitrogen ratio of a variety of different products would be. And I don't want us to get too tied up in all the numbers here. Remember, we're looking for that 25 to 30 to 1 ratio for carbon to nitrogen. And so when we look at all of these things, of course, we can see, where cow manure is or where grass clippings would be. Well, we do see that our yard and our kitchen waste, really the grass we might pull off of our, from cutting the grass, any vegetables or fruit materials that we might not be using in the kitchen that would otherwise be thrown away are really kind of right at the ratio we need to be. So that's a wonderful place to start with your compost bin, are those materials that are right there in your home environment. Now, very often we do have other materials that we do want to add in. So we might want to add in something like cardboard, or we may have some pine bark that we want to compost. And it's a really good idea to kind of have the idea that when you add in something like cardboard or you add in something like pine bark, you really need to add in a nitrogen source along with that, because they have that really high carbon to nitrogen ratio. So we need to counteract that a little bit, either by adding a lot more yard and kitchen waste to make up that difference, or really just adding that nitrogen fertilizer is what's providing a lot of the extra nitrogen that we need in order to make sure that our compost is working effectively. Another really important factor in composting is the size of the materials that we're working with. So the smaller the particle that we're working with, the better that composting process is going to happen. So you can kind of think, if you have something that has a really large diameter, that's about the size of a softball, that material, if you think about the area of its surface in relation to the overall mass of that material, it's got a pretty low surface area to volume ratio. So it's got a lot of volume, but not a lot of surface area. If you go down to a much smaller size, as you get smaller and smaller, you're going to wind up with closer to a 1-to-1 ratio when we talk about the surface area of that object to its volume. So it's a lot easier for microorganisms to get all around that material and really work on it and break it down fast if it's already in a pretty small size. And that's really what that chart is showing. You can see that 1-inch diameter material is going up to that 160-degree temperature a lot faster. It's going through that entire process of the 3 stages of compost much quicker than as you start increasing the size of that particle. So any waste material, even the things that you're bringing out of your kitchen, need to be broken down as easy as it is practical to do so. You can use your kitchen knife in the kitchen to break down those materials and chop them up a little bit. You can use your mower to go over the materials to chop them up, and just shred them or chip them as much as you can. If you're putting in brush or tree limbs, things like that, you really do need to chip those down to a smaller size. One of my first experiences with composting was long before I had the opportunity to really learn about it. And I just piled up a lot of old plants over in a big pile and thought, well, they'll go over there and they'll compost. And a couple of years later, you could walk over there and you'd still see the plants just laying there, because they're in such a large size that they're just not able to break down quickly. So chopping up those materials really does make the process of composting happen a lot faster. Now, there are some things that we do want to consider as not being the best materials to add into our compost. And this really comes down to 2 factors. We don't want to have anything in our compost that when we use the compost might cause us problems. And we don't want to put anything in there that's going to make the compost pile itself a nuisance. So if you're growing plants in your vegetable garden and you have a plant that's severely affected by a disease, you don't want to put that into your compost pile, because it's possible that even the high temperatures that you get in composting may not completely destroy those disease organisms, And then when you move that compost back into your garden, it's possible that you might reintroduce that disease. Kind of similarly, if you have weedy plants, if you've weeded your garden, and some of those plants have gone to seed, you don't want to add those weed seeds into your compost. Again, they can survive through the process of composting. And then as you reintroduce the compost into your garden, you wind up reintroducing the seeds and increasing your weed problems. The other thing, and this is more a matter of opinion, if you have animal products like greases or fats and oils, meat scraps, those can attract wildlife. So either the family dog or actual wildlife can come in and may want to dig around in your compost pile, which can cause you some problems. It's also a problem as those decompose. They can make some odors that are not pleasant. So again, you may want to consider that as you're thinking about what you're going to be adding into your compost pile. Generally speaking, the materials from preserved wood these days aren't a big issue, but if you have some really old wood laying around, you do want to consider if it's preserved wood, may not be the best thing to add into your compost pile. Another thing that is important is to turn your compost pile. So now that we've got it started, we've got the right materials in it, we need to make sure that we're mixing that compost about every 2 weeks. What we're doing as we're mixing our compost pile or turning it is to make sure that we allow oxygen to get into all of the interior of that material. Those microorganisms that are doing the work of decomposition require oxygen to spread and to live. And so making sure we have that is really going to help speed up that composting process, make sure that we have good, healthy bacteria and fungi down in that compost pile, turning it into great compost for us. I did mention moisture level. Ideally, what we want for our compost is a water level of 50% moisture by weight. Once that pile starts to dry out, if the water level gets down below 15%, we'll actually completely end the process of composting. So if we have periods of time kind of like right now where we've had limited rain, it may be necessary to actually water our compost pile to make sure that we are keeping up a really good level of moisture in there. Now, similarly, we can have a problem with overwatering. If the compost gets to a point where it's completely waterlogged, all of those good bacteria and fungi that we're wanting to have in our compost pile are aerobic bacteria. They need oxygen. And there are some other kinds of bacteria called anaerobic bacteria. And that is going to promote those anaerobic bacteria. It's going to stop the process of composting. And generally, those anaerobic bacteria tend to smell pretty bad. So one of the easy diagnoses is if your compost pile doesn't smell really good, it's a really likely reason is that there is too much water. That compost pile has gotten waterlogged. Those anaerobic bacteria are working and causing that bad smell. So now when you add materials to your compost, you are adding water. Particularly things like food waste and yard waste do have a pretty high water content initially. You can use bulk materials like sawdust or cardboard or those brown compost materials to lower down the water content of your compost to make sure you get it around about that right target. Now, there are some really fancy ways to figure out if your compost has the right water content. You can use a scale and try to measure it by weight. But it's a lot easier just to use kind of a really practical way of testing whether you're at the right moisture level. And if you pick up a small amount of your compost and just squeeze it in your hand, you should have just a small amount of water drip out of it when you tightly squeeze it. And it should, in your hand, feel about as moist as a wrung out sponge does. So if it's more wet than that, you need to let it dry out. If it feels really, really dry, you're going to need to add some water in order to make that compost work for you. Now, finished compost is really easy to work with. You can use it basically when that pile cools back down to an ambient temperature. It is going to have a really dark color to it, be really crumbly. It's not going to smell bad at all. It's going to have this really nice, fresh, earthy smell to it. And again, that process can take about 6 months in order to fully complete. And again, one of the best ways to do that is get a compost thermometer. You can use that to monitor the temperature of your compost and see when it's done working. So I want to spend just a couple of minutes, just a few minutes today, talking about vermicompost. And vermicompost is kind of just like compost, but instead of relying on microorganisms, we are relying on worms. So vermicompost is a really finely divided peat-like material that is produced by earthworms. It is very good for improving the structure and aeration and drainage of your soil. And it has some interesting effects on improving the growth and performance of vegetables and flowering plants. So just to compare two different compost methods, we have our traditional compost and then our vermicompost. And traditional compost, again, is that process using microorganisms, goes through those heating stages. We do need to turn it in order to make sure it keeps working, and it might take several months in order to fully go through that process. By contrast, vermicompost is using both earthworms and microorganisms. Does not have to go through that thermophilic stage, so it's never going to get up to those high temperatures. And the worms do all of the work of turning and fragmenting and aerating that material, so you don't have to get out there with pitchfork and turn it over. The other advantage of vermicompost is rather than taking potentially 6 months, vermicomposting can actually occur just over a period of a couple of days. So 1 pound of worms can actually convert a pound of waste into vermicompost in just 48 hours. And you can see there a good picture of worms going to work in that soil to turn over that material. In terms of benefits of vermicompost, using it in your media can produce an increase in plant growth. It's going to increase the vigor of the plants, and it has a more positive effect on seedlings than it may have on larger plants. Biggest use that I get out of vermicompost is when I'm starting seeds. So I try to grow all the plants that I use in my garden from seeds as much as I possibly can. And vermicompost is a really important component of that seed starter that I use. So again, vermicomposting, we're going to be able to get that material worked in just a couple of days. And there are a couple of different species of worms that are really commonly used for vermicomposting. And they're both in the genus Icenia. I don't want to get too hung up on that. The really common one are called red wigglers or red worms. Occasionally you'll see red tiger worms. But the easiest worms to use for vermicomposting are some of the worms that we would otherwise use as fish bait. So if you go to a bait store or other place where you might be buying worms to use as a bait, if you look on the label for those, you'll either see the words red wigglers, or sometimes you'll see the actual scientific name, Icenia hortus. And hortus is the fancy science way of saying plant. So we know that those worms are going to be really good for use in vermicomposting. So here is how vermicompost works. We take soil in a container, we add in a thin layer of organic waste on top of that. Worms like to come up to the surface in order to feed, and that will also help us keep the worms up at the top of the bin. So when we decide that we've gotten that vermicompost material to a depth we like, we can take off the bottom layer, and that doesn't make us have to sort out too many worms. what we'll very often do is we'll have a screen on the bottom of that container, and then we can just shake the vermicompost right out of the bin into another container. That allows us to make sure we're keeping all the worms, add in more soil and add in more material for them to eat, and start the process all over again. As far as how to use vermicompost, you don't have to use a ton of it to have a pretty significant impact on plant growth. About a fourth to a half a cup around the base of plants that are currently going into the ground works very well in order to support their growth. And it doesn't replace fertilizer, but it does boost plant growth. You can see a picture down there of some flowers where they have compared the growth of the plants without any vermicompost, and then with a 30% addition of vermicompost as a soil additive. And you can just dramatically see the difference between those two plants. One's already up and flowering while the other one hasn't even put on blooms yet. So obviously it has a pretty significant impact on plant growth. Now, one of the things that I consider really interesting about vermicompost is we're not entirely certain why it has this effect. It absolutely does increase soil growth up to a point. After you get too much of it, if you go past about 20%, you actually do see a decline in plant growth. We're not really sure if it's a fertilizer thing or a soil structure thing. I put up a picture of a video game character from when I was a kid named Earthworm Jim, who was the world's first worm superhero. And I have declared that he is the reason why vermicompost works so well. I just think that's a good answer to the question. So with that, those are my comments on on composting and vermicomposting. I would very much appreciate any questions that you might have. And I do see that there are a couple of questions that are over there in the chat area, and I'll try to address those. If you have, how much sunlight do you need for the compost bin area? Sunlight's really not that important for compost. You just want to make sure it's in an area where it's not going to get wet and stay wet. So a little bit of air movement is a good idea. You just need to be aware that if it gets wet, you may have trouble with it staying wet if it's in a really shady place. Bad fungus and molds in compost. I haven't seen that as a problem very often. If you're turning your compost and it's getting up to those active temperatures, you shouldn't have molds forming. If you do get mold in your compost, it's really a sign that it has gotten wet and stayed wet. So again, turning your compost, keeping that moisture level down is really going to be a significant factor in making sure we don't have any problems. As far as whether you can add meat or fish, again, that is something that you want to consider. If you do add meat materials, whether they be meat or fish, you do have the potential for drawing in wildlife. And I know I included a lot of examples of different materials. Fish, ground up fish or fish emulsion were on that list, kind of just to show what the different ratios of materials would be. What is your vermicompost to regular dirt ratio for seedlings? I use 20% vermicompost to the regular soil that I would use. So that's 1 part vermicompost to 4 parts of the regular soil. Is black soldier fly larvae or worm in a compost a good thing? My general perspective on that is they're just fine. All those insects in your compost are doing is going to be further breaking down those materials. So a little bit of some flies in there helping to break down those materials is going to be a good idea. Please add comments about composting a container, such as a garbage can that has drilled holes. So long as you have good good water management in that container, as long as it's got enough drainage to make sure that it doesn't stay wet, then that'll be just fine. You do need to make sure you're turning it to get the oxygen content in there up. So if I just had a container with some drilled holes, I might suggest turning it a little bit more often to make sure that air is able to penetrate down into that container and get everything that needs to happen down in there. Really monitor your temperature. It is a good idea to have a compost thermometer for that. They're relatively inexpensive. It's just looks like a big meat thermometer. It just has a really long probe. And that'll make sure that you have all the compost going where it needs to be. Do you need to remove the top layer of grass to start a compost pile? You can hopefully clarify that question if I'm going to answer this a little bit wrong, or if I'm answering a question that you're not asking. If you have your compost pile built on an area that has grass, no, you don't need to remove the grass from underneath the compost pile. Having the compost pile on top of the grass, of course, is going to block the sunlight for that grass, and it will die back. So that won't really be a big issue for you. One thing that you do want to note, and I mentioned this about materials a little bit, particularly you do want to be conscious as you're adding materials into your compost if there's a lot of water in them. So I've seen that problem with cut grass fairly often. So if you are collecting the grass clippings as you're mowing, which I don't recommend, then those materials tend to be very wet and they just have a high water content. So if you're adding anything in with that really high water content, again, you either want to let that sit for a while and dry before you add it into your compost pile, or you want to make sure you're adding in a material at the same time that's going to kind of counterbalance the amount of water that you're putting in, and keep it down to that 50% level, so that you don't wind up with it getting into that condition where you have an anaerobic bacteria growing. And again, the simple test for compost to make sure that it's working effectively, of course, is one, to check the temperature. But compost should not be something that smells bad. So if you do have a really bad odor coming out of your compost, that is a pretty clear sign that something has gone wrong. So you can always use that as a method to ensure that your compost is working.